from any device, any place, anytime, whether it's a PC at someone's house or a laptop in a connected state or a thin client sitting on or underneath someone's desk. All I really need is to have access to a network to be able to see that desktop. That desktop no longer lives underneath the cube. It lives in the data center, and its data is there. I can remove and present applications to it in a lot quicker fashion than over LAN links, perhaps. It's being presented from one rack of servers to another. And then, of course, users' profiles. We get away from a lot of the intrinsic pain of having to present roaming profiles out across the network. And there's a lot of different stuff that you're probably hearing about. So I thought I'd take a quick second and just kind of level set here, whether it's VDI was on desktop or desktop clouds or application clouds or storage clouds. We're all kind of sort of saying the same thing, which is take the way that computer was architected apart and find new and perhaps more beneficial ways to put it back together, that solves, I guess, that high order bit we started with, which is help me create a more reliable computer system out of all of these intrinsically, unreliable parts. Another real event that's upon us, whether we like to think about it or not, is the presence of Windows 7, and the knowledge that, the operating system that we've used for the past, oh gosh, when did it come out? Probably 9 years, is not the one that we're going to be using in the future, or at least it probably won't be. And so there's a whole new stack of exploration and understanding that we need to get our heads around and our hands around. Say, okay, well, how does Windows 7 change the way I architect and deliver desktops? A lot of organizations that I've had the pleasure to work with are actually using that event horizon. Windows 7 being upon us is a very interesting place to dive into this world, or at least the exploration of desktop virtualization. But the goal is really the same. What we're trying to create is that reliable computer system that gives my users a productive work environment and is easy and productive on my budget. So what do we do? This will be less about me and more about the process, I think. So here's my one infomercial slide, which is that, well, actually, I can't promise that. There's a couple that we'll talk about the software because I think it's core to the process. But what we provide and what we're all about is visibility. So we're a software tool set that provides visibility from the endpoint to the network through connection brokers, servers, hosts, storage, cloud, etc., before, during, and after. And so what I'm going to spend some time talking about today is the before. What do we do before we start diving into this brave new world in terms of how to engage and how to explore these technologies? So I start with assessment. In a perfect world, and I'm a car nut, so I'll give you a car analogy. In a perfect world, I'd love us all to be able to lift up the hood of our organization and take a look around and see what's under the hood. I'd want to look at all my users. I want to categorize all my users. I want to see all of my applications. I want to see how those applications were used, who was using them, at what time of day, how often, etc. I'd like to look at how they consume CPU, memory, disk, I/O, how they're chatting on the network, how they're chatting to local hard drives. I'd like to also look at the environmental limit that my users have. What are the speeds and sizes of my LAN pipes? What are the speed and sizes and latency of remote links that might be coming into that environment? And in a perfect world, I'd like to take those measurements and I'd like to move on to a design phase. A number of us did not start with an assessment, but that's okay because it is absolutely appropriate each and every day to reassess. And what I mean by that is a number of organizations, and you might be among them, went straight to deployment. We heard about this new technology, maybe VDI, maybe it was something else, and we stood up 10, 20, 50 seats, and we kind of stared at it. And it was a fun science experiment, and it really didn't give us a sense of reduced risk that it would actually work for us. We tried to run numbers, it was too expensive. We tried to administer it, it was too complex. Well, a lot of that, I'm here to tell you, I think stems from not having the design right, and the design isn't right because we didn't do a proper assessment. So in a perfect world, we'd assess, we take these measurements, we'd use that as the basis for a design. We'd then move on to the deployment phase of things, where we'd stand up an environment that actually resembles what the real world environment should look like or could look like based on the observations that we made. And the goal is really the same, which is to eventually get to a manageable end state where I'm able to present a reliable computer system out of what seem to be somewhat complex and disjointed parts. That's the goal. And I'm here to tell you that it's not a monumental undertaking. It still amazes me every day how large customers, I had my glory slide up there before, that was partially NDA, but we'll pick on one. So let's say, for example, the nation's largest retailer. Here's an organization that might have gotten a few thousand seats deep in desktop virtualization without having done a proper assessment, and really was willing to stop the train for a month or two and take a real heavy look around at both their existing deployment as well as the other 60 or 70,000 users in the organization to say, wait a second, there's some things we missed. There are things our users do in the course of a day which will affect the vendor decisions that we make, the architectural decisions that we make, the operational and procedure with which we manage this environment. So let's not start over, but let's just undo some bad decisions and start making some good ones. I'm a huge fan that good data helps us make really, really good decisions. And so when I think about the process, it goes something like this. I mean, there definitely are challenges and barriers to the adoption of any new technology. And in the world of desktop, as we see it playing out, they go something like this. Number one, it is typically had been a fairly difficult endeavor to select the right users to be virtualized or migrated to this new stuff in the first place. A lot of us thought, and we were partially right, that it was the call center. It was the task worker. It was somebody that was attached to the LAN that came in at 9 and left at 5 and really didn't use too many complex apps. That was going to be the best place to start. Maybe that's the case. However, if I was actually going to explore what my users are up to today, and I'll show you how we do this in a few slides, I might find either a slightly different answer, or I might validate the answer that I thought I had, which is, okay, the following population are the right ones to start with. Not only that, as I start moving on to the design phase, I want to ensure that, that it's viable. And the one trick with desktop virtualization is that things break in a nonlinear fashion. What I mean by that is that a 10-user pilot does not equal 100 users, does not equal 1,000 users, does not equal 10,000 users. And the path at which and the time at which things will break, or the tiles will come off the space shuttle, so to speak, is very unpredictable. And that's basically because when you talk about large populations of users, even though they might be in similar organizational units, even though they might be doing similar jobs, oftentimes they do them in radically different ways. Just because they're in accounting, one user comes in, clicks on Excel, and then checks Outlook. The other user comes in and does Facebook, and then Outlook, and then Excel. And just that very slight difference in their usage pattern actually is a fairly meaningful difference when we talk about the architecture. So the architecture has to be viable. Not only that, as we start rolling these things out, as we start testing, I'm a huge fan and believer that if you can measure it, it matters. That's actually a line from Intel. And if you can measure it, you can also manage it. Jokingly on my graphic here on the side, here's a user down at the bottom saying, help, my computer is slow. For the most part, we as desktop administrators have not had great visibility into what slow means. We might try to reverse engineer what that user did. We might try to look at the apps or the warnings or the alerts that we're getting from that desktop. But today, with our kind of distributed and very connected world, oftentimes slow has nothing to do with what's happening in that user's or on that user's desktop. It might be something on the network, might be something in storage, might be an application server, excuse me, might be a cloud-based resource, could be a number of different things. And so what we do with our software, whether it's during the assessment or the health check or the architectural phase, is arm great partners like CentriNet with the tool to say, aha, we know what that is. We know what slow means. And guess what? We can fix it. Or we see what slow means. We can't fix it, so we're going to take it in a slightly different direction. We're going to recommend some different architectures or different platforms or different products or different amounts. It gets really, really powerful when you have great visibility because nothing surprises you. And if it does surprise you, being able to pinpoint what the surprise was and then remediate it becomes a lot less painful, I think, than finger pointing. In the early days of virtual desktop, at least,